All right, welcome back to Rock the JVM. I'm Daniel, and in this video, I'm going to talk about mutability in Scala. Now, this video is a little bit more beginner-friendly. However, I'm going to show you some techniques that are less known in the Scala world, so there might be one or two things in this video that you might find new. Now, as always, I'll recommend that you code with me and just refer back to this video or to its written form at the blog whenever you need to refresh your memory about these concepts. So I'm going to talk about mutability in Scala, and the techniques that I'm going to show you have both been tested on Scala 2 and Scala 3. In particular, I have a Scala 3 project, but this code works just as fine in Scala 2. So learning functional programming requires us to unlearn some habits and learn new ones, because most of the folks learning Scala have probably had more experience with another programming language. I'm guessing either Java or Python or C or C++. My experience was C as my first programming language, but most of these languages, the more standard ones, are imperative. And so the first things that we learn is how to mutate variables or how to mutate arrays. So learning functional programming in Scala causes us to unlearn some of these habits. However, we still have the notion of a variable or mutation deeply ingrained in our software engineering skills. So I'm going to show you a few techniques on how to do that in Scala. And Scala has the concept of a changeable variable, which is denoted by the keyword var. So normally we have Scala working with values, VAL, and I'm going to define one with meaning of life as 42, but you can have variables with the keyword var, and I'm going to say, let's call this mutable meaning equals 42, and then after you define a var, you can change it, you can reassign it by saying mutable meaning equals something else like 45. Now, chances are you will find this thing trivial. However, for some of you watching this video, it may very well be surprising because I normally do not teach variables as one of the first things in Scala. In my first days as an instructor, I used to teach Scala with values and variables in the same first lesson, but then I learned and later wrote about and filmed the video here at Rock the JVM how learning variables here actually deters from learning and teaching pure functional programming because it keeps people in their current mental model with mutation. And learning FP is a different style of thinking, and changing variables in this way actually prevents the unlearning necessary. However, after having a taste of pure functional programming, I then show my audience variables and mutation, which can then more wisely integrate into their mental model. So this is the first technique that I wanted to show you around mutation, which is mutable variables, which means that you can simply reassign a variable to another value of the same type. The second technique, which is a little bit lesser known, is how to mutate a data structure. And mutating a data structure in the form of a class merely involves defining a variable field, which you can then reassign, but there's another technique that I want to show you here, which is getters and setters in Scala, which have a special kind of form. Now, I've never quite been fond of the Java getters and setters when all they did was just to access a private field. That would be functionally identical to making that field public, perhaps except making those getters and setters synchronized or thread safe, but let's be honest, almost nobody does that. Now, getters and setters can also be used to do something else besides just accessing that field. For example, perform a side effect like logging how many times a field was accessed. Now, although I would not recommend that in general, there are some use cases where getters and setters can be useful with side effects if written with care. So I'm going to, for the sake of demonstration, show you a person class and how to mutate it with getters and setters in Scala natively. And what do I mean by that? It's going to become apparent shortly. So I'm going to define a class called person, and I'm going to have two arguments here, a name as a string and age as an int. And I'm going to denote age by a, just for shorthand. I'm going to make both of these constructor arguments private vars. So we cannot access these from the outside. Okay? Now, even though these fields are private, we can obviously still construct this class with the right constructor arguments. So for example, if I define a val called Alice, is new person with the name Alice and the age 25, for example. right? So even though these are private vars, I can still pass them as constructor arguments. I cannot access them though. And if we wanted to mutate Alice's age, we would need to add some code to the person class. And I'm going to write a very special kind of code. I'm going to define a method called age, and I'm going to leave it just like that and returning an int. So no parentheses here and no arguments. And I'm going to perform a side effect here, and I'm going to define var here inside the person class, which is, for example, the number of accesses of age, or nAge access, which is the number of times this field was accessed. And I'm going to increment this by 1. So I'm going to say nAge access plus equals 1, and then I'm going to return a, the private field of person. So for example, if I wanted to obtain Alice's age, I would say Alice's age equals alice.age. So this would look as if Alice had a public field called age, and I could access it just like that. This is why the methods with no parentheses were invented. This is called accessor or getter methods. All right. Now, we can also mutate Alice's age by defining a very, very special method with a special form. I'm going to define a method called age, which has the exact same name as the getter one, and then I'm going to append it with a very special kind of token, underscore equals. So the method name is age underscore equals, and as argument, this will receive an int argument. So I'm going to pass a new age as an int, and the return type must be unit. And I'm going to perform a side effect. For example, logging something, logging that this person has changed their age. So I'm going to simply print line or use a logger or something. And I'm going to say person N has changed age from A to new age. And then I'm going to perform a mutation by saying A equals new age. The private field was changed for the argument here. Now, once you define a getter in this form, and this other method with this exact structure, like age underscore equals with an int argument returning unit, then I will be able to say, and this is going to be probably interesting, I'm going to say alice.age equals 25. And this is acceptable to the compiler because it's rewritten as alice.age underscore equals with the argument 25. So this is sugar. And if you look at lines 28 and 29 here, these two lines, it seems as though the person class, this Alice instance, has a public field called age. So it's as if you're exposing a public field with a logic of your choosing. Now, as I said before, this logic with side effects needs to be done very, very, very carefully with a really solid reason for you to do this sort of thing. All right. Cool. Now, for this thing to work, you will need both the getter and setter present and with this exact structure. So you need to have def some field colon your type, and the setter needs to have the exact structure of your field underscore equals, and this needs to receive exactly one argument of the exact same type that the getter has, and this needs to return unit. All right. Cool. So this is one of the techniques which allows you to create a mutable data structure with the logic of your choosing. Now, the second technique that I want to show you is how to update data in collections. What do I mean by that? Most of us programmers have grown used to arrays because they're very easy to use and easy to understand. So if you were to write some Java code, you would write something like int square brackets array equals new int with the dimension 2, and then you would say array at index 1 equals, I don't know, 56 or whatever. All right. So this is very, very common in Java code or in procedural code in general. Now, in Scala, we also have the array data structure, which is directly mapped to the JVM native arrays backed by Java. Now, Scala allows us to create mutable data structures with the update semantics of arrays. In other words, we can define classes which are updatable much like arrays. Now, let's assume we created a person data structure. Let's call this Bob. So I'm going to call this Bob equals new person with the name Bob and the age, let's say 23. And we would be able to access the fields of this person class indexed by their number. So for example, the name would be at index 0 and age would be at index 1. So I would like to be able to say val Bob's age equals Bob at index 0, much like we used to do with arrays. So we can do that, and this particular line is pretty easy to implement. I'm pretty sure you're familiar with a special method in Scala called apply. So I'm going to define a method called apply, and I'm going to make this apply receive an argument. Let's call this index, which is an int. And I'm going to pattern match this index against the numbers 0 and 1, because that's the only two indices that I want to support. So I'm going to say index match, in case 0, I'm going to return n, and in case 1, I'm going to return a, and in case whatever, I'm going to throw a new, let's call this index out of bounds exception. Okay, so apply will return one of the fields depending on the index. So now if I have an apply method, then I can uncomment this line and the compiler will be able to compile this for me, because Bob applied to 0 is equal to bob.apply at index 0. Okay, so invoking an instance with an argument is the same as running its apply method, which I'm pretty sure you know by now. Now, updating it, that is, updating a value at a given index and taking a certain value, will require another special method which is less known in the Scala world, which is called update. An update can take two arguments: an index which necessarily has to be an int, and a second argument which can be of any type. And I'm going to use any because the name and an age are of different types. So I'm going to say value of type any, and this can return any type. It usually returns unit. And I'm going to say index match, and in case the index is 0, I'm going to say n equals value as instance of string, because value is of type any. And although I hate typecasts like this, it needs to happen here for this use case. So just take this example for what it is. And in case we get 1, we need to update the age. And I'm going to simply invoke this setter over here. So I'm going to say age equals value as instance of int. And in case I get something else, I'm going to throw new index out of bounds exception. All right, so now after I've created this update method, I can then say bob1 equals 24. So if I write bob apply to 1 equals 24, the compiler rewrites this entire line with bob.update at index 1 and with the value 24. So we've basically defined an API that will allow you to mutate your data structure with your own logic with the same semantics as arrays. So accessing a field like you do with arrays and mutating a field like you would on arrays. So this video focused on how to create mutable data structures in Scala that feel natively mutable. Now, hopefully at least one of the techniques that I've shown here, I'm guessing either the setter or the update method, were new to you, and you'll find them useful the next time you'll need mutability in Scala. Now, if you like this video, go ahead and click the like button for me and subscribe to the channel for more content like this, and follow me on Twitter and LinkedIn as I post fresh updates on upcoming material. Now, I'm dying for feedback, so please leave your comments in the section. I read every single one, and check out the blog and the Rock the JVM website. I have tons of content related to Scala and cats and Akka and functional programming and Apache Spark and so much more. Now, until next time, I'm Daniel. Thanks for listening.